Hey, what's up? Welcome to this new video. This one is paper 1-3 of May-June 2010 of A-level math, obviously. Now, with that being said, let's move on to question number 1. So here, what do we have? The first term of a GP is 12. Okay, first term is A, so A is 12. And the second term is minus 6. So second term, T of 2 is minus 6. These are the given information. Now, part 1. We have to find the 10th term of the progression. So 10th term, T of 10. Okay, so now we understand this one is a GP. So the first thing we can do is let's first write down the formulas we know for this kind of progression. So we know that the nth term is going to be a r n minus 1. Sum to infinity will be what? A over 1 minus r. Now, since we know those two are given to you, by the way, so you don't need to memorize them. However, I think it's best to memorize them because you won't waste time looking for them in your list. Now, let's move on. So we're trying to find the 10th term. Now, we know the value of A is 12, but we don't know the value of R, so we can first find the value of R. So pretty easy. We're given the first term is 12, second term is minus 6. So now we understand that from the first term to go to the second term, what do? We multiply by r. So we know 12r is minus 6. So r should be what? Minus 6 divided by 12, that should be minus half. There you go. So value of r should be minus half. Now this is one way of doing this, that we understand what happens between the terms, because that's how you call a geometric progression. Now again, if you don't know what I did just here, you can just use the formula directly. For example, I know the second term is minus 6, replace here. So second term where n is 2, that is minus 6 is equal to A is 12 given to you, R we don't know, n is 2, second term, 2 minus 1 is 1. So here we have our equation. Solve for R will be minus half again. Okay, so what's next? So we know R, we know A. Now we have to find the 10th term. Pretty easy. 10th term, replace back in the equation. A is 12, R is minus half, and A is 10, minus 1 should be 9. So let's see what do we have. So minus half power 9 times 12. That should be minus 3 over 128. That should be part 1 of your question. Now for part 2, we have to find the sum to infinity. So again, as you can see, this is the formula we have to use. So sum to infinity will be A is 12, the first term, and 1 minus R is minus half. So here we go. This divided by 1 minus half, that should be 8. So 8 will be the sum to infinity. Let's move on to the next question. So find the first 3 terms in descending powers of x of this expansion. So pretty easy. We'll just have to expand the first 3 terms. You will have 6, choose 0. Here we have x, and here we have minus 2 over x. Because we have 0 here, here will be 0 as well, and here we have 6 minus 0, that should be 6. And then we have 6, choose 1, x here, and minus 2 over x. Here we have 1, that will be 1, and here we have 6 minus 1 is 5. And finally, 6, choose 2, x minus 2 over x, that should be 2 here, and that should be 4 here. Now we just have to expand and simplify to see what happens. So here we have 6 choose 0 will be 1, that should be this, that should be 1, plus 6 power 5 minus 2 over x. What is 6 combination 2? Let's see, that should be 15. And then that should be x power 4, and that should be 4 over x power 2. So simplify, cancel, that should be 4 here, and here we have cancel, that should be 2 here. Now let's simplify. Here we have x power 6, and here we have minus 12x power 4, and here we have plus 60 x power 2. As you can see, they are in descending powers of x, so x power 6, x power 4, and x power 2. The first 3 terms in descending powers of x. Now that is part 1 of your question. Now for part 2, we have to find the coefficient of x power 4 in this expansion. Okay, so here we have part 2, we have 1 plus x squared multiplied by this. Now again, this is what? It is from part 1. We have realized this gives you this. So just write this here, right? So you will have this one for part 2 of the question. Now, how would you expand this? So one by one, usually you will take the first one here, multiply by the whole thing, right? And then here we have plus x squared multiplied by the whole thing. That's how you would expand those brackets. But now we understand that we only care about the term in x power 4, so we can choose, pick and choose. So 1 times which one will give you something in x power 4? This one. So 1 times minus 12 will be minus 12 x power 4. Here we have plus, we have plus. Now here we have x squared times which one will give you x power 4 times this one, obviously. You have 60 x power 4. Because that's what we care about in this question. Now simplify. Minus 12 plus 60, that should be 48. So we have 48 x power 4. And now the coefficient is just a number in front of that. Should be just that. So your answer is only 48. Let's move on to the next question. The function f is equal to a plus b cos x. Okay, that's the definition. Is defined for the domain of 0 and 2 pi. So if you want to work with degrees, it is between 0 degrees and 360 degrees. Right, anyways, that's just a way for you to kind of have a different look or view about the angles in radians. Now, we're given two values here. When f of 0, given that f of 0 is 10, and f of 2/3 pi is 1. So we have to use these to find the values of a and b. Okay, so let's proceed step by step. So first we have f taking the value of 0. That will be a plus b cos of 0 should be 10. This is given to you by the question. Now simplify. What is cos of 0? Should be 1. So a plus b times 1 is b, should be 10. That is your equation number 1. Now for part 2, we have to use this one. F 2/3 pi should be what? A plus b cos of 2/3 pi is equal to 1. So let's use that. Cos of 2 pi over 3. We have to use radians here. As you can see by the question, that will be a plus b times minus 0.5 is equal to 1. That is my equation number 2. Now as you can see, we have 3 equations, and with 2 unknowns, which is a and b, we can solve simultaneously to find the values of a and b. So let's try to do something here. Let me make a that become the subject. That will be 10 minus b. Again, there's no reason why, just my preference. I thought it was easy to make a become subject, and that's why I did that. Not because there's any special reason why. It's because I thought it was easier for me. But now if you guys want to make b, it's up to you as well. Okay. Now replace a back in here. You will have 10 minus b plus minus 0.5 b has to be 1. Now we have to send this one over here. You will have what? So here we have minus 1 minus 0.5 is minus 1.5, right? B, that should be 1 minus 10 should be minus 9. So b will be minus 9 divided by minus 1.5. That will be 6. Value of b is 6, so we can replace back in the main equation over here to find the value of a. 10 minus 6 will be 4. So part 1 done. So a is 4 and b is 6. That is right here. Now for part 2, we have to state the range of f. So let me write down f of x right now. So right now we realize f of x is given to you by a plus b cos x. A is 4 plus 6 cos x. Right? This is f of x. Now something we can observe. 4 is a constant, it will not change, and 6 is a multiple, but it will not change. The only thing changing here is this one. Right. Now we understand that when x is between 0 and 2 pi, cos of x can only be between -1 and 1. So these are the values to which cos of x can go. It cannot be more than this. So just replace. We have our first option, when cos of x is -1. That will be what? That will be -2. And then the other option is when cos of x is just 1, that should be 10. So obviously the range will be between those two. Range is defined by y, or you can write f as well, is between the values of -2 and 10. So this is part 2 of the question. Now for part 3, we have to find the exact value of this one. Okay, so let's find out. So here we have to find f of 5/6 pi. That should be 4 plus 6 cos 5/6 pi. So let's try to simplify and see what do we get. So cos of 5 pi over 6, it is in radians, that is, so minus 0.8666. So I've seen this one many times before. I guess it is from practice that I kind of know that it is the same thing as √3/2. It is those angles you have to know that give you exact values. For example, I had this, right? Let me check. √3 divided by 2 should give you this one, and it's just negative here, so it's the same thing. Confirm this should be actually this. So 4 plus 6. Now again, I think if you guys use a different calculator, it will give you the exact value directly, so you guys don't have to worry too much about this one. However, if you guys don't have that option, as you can see, we kind of have to know the exact value of those angles. There's there's practice, there's a lot of repetition, and over time, don't worry too much about this. You have the more questions you do, the more angles you will see and the more values you will see how they are kind of similar to each other. So in this case, I did realize that when I saw this one, for example, when I saw the 0.866, I know that I had to do something with √3/2, because you know that cos of 30 is the same thing. So sorry, degrees, same thing. But now we understand cos of 30 is positive because it is in the first quadrant. But now what is 5/6? So 5 times 180 divided by 6. It is just 150. It will be in the second quadrant. Now cos of an angle over second quadrant will be negative, obviously. And as you can see, cos of 150 will be negative 0.866. Now I know 866 is the exact value of this one. For example, cos of 30 is equal to √3/2. You have to know the exact values for those angles. But now what is cos of 150? It is just 180 minus 30, right? Which should be minus cos of 30. Should be minus √3/2. Again, no big deal. You guys don't have to memorize this or that. It's just over time, by practice and practice, you will see what it is and you will know exactly what to do. But now again, if you guys can write this down for yourself, that will be great as well. Let's move on to the next question. Here we have to show the equation here can be expressed as this. So let's begin. As we can see here, we have cos, we don't have sine or tan. So let's see what can we do to make them become cos, right? That's the main idea that I have. So here we have 2 sin x. Here we have tan x. Tan x could be sin x over cos x, right? And we have plus 3 have to be 0. Now, to cancel out the denominator, I can multiply by cos x everywhere. So I can remove the denominator. You'll have 2 sine square x, because we have sin x times sin x. Now obviously this will go away, because when you multiply by this everywhere, this will cancel out. And here we have plus 3 cos x have to be 0. Now simplify. We do know that sin x is what? It is 1 minus cos square x plus 3 cos x have to be 0. 2 minus 2 cos square x plus 3 cos x have to be 0. So finally 2 cos square x minus 3 cos x minus 2 have to be 0. And this is shown as required, part 1. Now for part 2, we have to solve the equation between the values of x between 0 and 360. Again, this is from part 1, and as you can see, part 1, we changed that to this, so we can just use this to solve this one, right? We know this is just solving this one. Let me do something here to make it easier for you. So let u is equal to cos of x. What will happen? You will see you will have 2u squared minus 3u minus 2 have to be 0. This is a simple quadratic equation. We can use factorization, or you can use your formula to solve the equation. That will be 2u times u, 2 times 1, minus 3 is minus 4 plus 1. U will be minus half, and u will be the value of 2. But now again, I'm not trying to find the value of u, I'm trying to find the value of cos x, of x. So u is cos x, have to be minus half, and cos x have to be 2. Now this one is not valid because we know cos x can only be between minus 1 and 1. You can check. Cos inverse of 2 is error, so it's not possible. So invalid. Now for this one, as we can see, the value of cos is negative. We have to look at the quadrants. So A, S, T, C, so everything is, so this is A, sine, tan, cos. When cos is negative, it will be in the second quadrant and in the third quadrant. Now here this will be, here it is degrees, so that will be 180 minus theta, and this will be 180 plus theta. Now here, this is theta. Theta is not your answer, by the way. It is an angle that I will use to find my answer, which is x. Now theta is what? Theta will be cos inverse of the positive value that we have over here. It is negative, but I'll take positive to find the value of theta. Theta will be cos inverse of 0.5. That should be 60 degrees. This is theta. Now we have to use our quadrants to find the value of x. So x will be, according to this, will be 180 minus theta is what? 180 minus 60 should be 120. Here will be 180 plus 60, that should be 240. So this is found by using your quadrants for the value of x. And that is part 2 of your question. Let's move on to the next question. The equation of a curve is such that dy by dx is given to you by this. Great. Now what is the first thing you can do? You understand that we can rewrite this equation. For example, I can write 6. I can take this up. That will become 3x minus 2 power minus half. I hope that makes sense because I know that square root is power half, and when you bring the power from the base to the top, the sign will change by the laws of indices, right? Now given that the curve passes through this one, through P, we have to find the equation of the normal of the curve at P. So again, pretty easy. We know that normal is a straight line. So something we know about normal is that the normal is a line which is perpendicular to the tangent. That's what we know about normals. At the point P. P is the point given to you as 211. Now we know they are perpendicular to each other. Now something that we have seen many times by now, the gradient of the normal, if you multiply by the gradient of the tangent, should be minus 1. So that's the relationship between them. So we have to use that to find the gradient of normal. But first we can find the gradient of tangent. But now we understand the gradient of tangent is simply dy by dx at that point. dy by dx at the point P, the value of x, is 2. Replace, you will have 6 over root of 3 times 2 minus 2 should be 4. And that should be 6 over 2, that should be 3. This is the gradient of tangent. So from this we derive gradient of normal should be minus 1 over 3. That is part 1 of what we can do. Now, since we have the gradient and we have the passing point, we can find the equation of the normal pretty easily. That will be my x value, my y value, so y minus its corresponding value over x minus its corresponding value should be equal to the gradient. Again, this is just the method that I use to find the equation of a line. If you have other methods, you can use them as well. I will be cross multiplying. You will have 3y minus 33, and that should be minus x plus 2. 3y should be minus x plus 35. And that is your equation of your normal, right? That is part 1 of your question. Now we have to find the equation of the curve. Now what is equation of the curve? It is the value of y. Now we understand y is equal to integration of dy by dx. Okay, so you have to know this to find the equation of the curve. So y will be integration of dy by dx is 6 3x minus 2 power minus half dx. Let's solve. So first thing first, 6 is only a multiple. We can take this outside, right? Then we have 3x minus 2. We can increase the power by 1, so minus half plus 1 should be half. Then divide by the same power, right? And then divide by d by dx, so the value inside should be 3. And that should be plus c at the end. This is y equal to this. Now simplify. 3 cancel out with this, that should be 2. Y should be 2 divided by half is 4 times 3x minus 2 power half plus c. So here we have to find c. To find c, we have to use the passing point given to you, which is p, 211. This is the x value and the y value. We place it back in your equation. That is 11 is equal to 4 times 3x minus 2 power half plus c. 11 is equal to, so x was 2 here, sorry. 3 times 2 minus 2 power half should be 2 times 4 should be 8. So 8 plus c. C will be 3. So finally we can write down the equation of the curve, which is y 4 root 3x minus 2 plus 3, because power half is simply square root. That is your question part 2 into finding the equation of the curve. Let's move on to the next question. Relative to a point O, the position vectors of A, B, and C are given to you by this. So OA, OB, OC are given to you by these vectors, right? Now part 1, use a scalar product to find the angle ABC. So pretty easy. From B, go to A, B, go to C. So let's find those two vectors. Find BA is simply OA minus OB. Right? OA is given to you by what? 1 minus 2, 4. OB is given to you by 3, 2, 8. So 1 minus 3 is minus 2. Minus 2 minus 3 is minus 4. 4 minus 8 is minus 4. That is BA. The next one is we have to find BC. By definition, we take this one first. Always to find this vector, we take the second one, OC minus OB. Now if you guys want to understand why it is in this way, I've made a video about this before. You can go check it out on the channel. Type in vector YAB is equal to something. You will see the video. Okay, so OC is minus 1, minus 2, 10 given to you. Minus B will be 3, 2, 8. Let's see what do we get. We get minus 1 minus 3 is minus 4, and 2. Okay. Now we have those two directions. We can find the angle between them, angle ABC. So that will be, by definition, or the formula we use is what it is. The sides BA dot product of BC is equal to magnitude of BA times the magnitude of BC cos of the angle B. So this is something we use, or we have to know when solving these kind of question. Now BA is what? It is minus 2, minus 4, dot of BC, minus 4, 2. The magnitude will be what? So we just have to square the values here. Minus 2 squares 4, plus 16, that is root of 36, and that will be also root of 36, cos of angle B. Now simplified, dot product will be minus 2 times minus 4, plus minus 4 times minus 4, plus minus 2 times 2. That should be 16. Divided by 36. Cos of angle B. So let's find out. 16 divided by 36 should be what? So from now we know cos of B is 0.444. So B will be cos inverse of that. Here you go, 63.6 degrees, correct to 1 decimal place for angles. That is part 1 of your question. Now for part 2, we have to find the perimeter of the triangle ABC, giving you an answer to 2 decimal place. So pretty easy, we just have to think in terms of triangle, right? So first we have A, B, and C. For example, let's say this is A, B, and C. This is the shape of a triangle. So to find the perimeter, we have to find the length on all 3 sides. So length of BC, as we have seen here, the magnitude of BA is root of 36. BC is also root of 36, right? Now we just have to find the length of AC. Now we have to find AC first. Now by definition, we can see AC will be what? Same thing, take the second one, OC minus OA. OC is minus 1 minus 2, 10. OA is 1 minus 2, 4. That will be minus 2, 0, and that should be 6. So what is the magnitude of AC? That should be 4 plus 36. That should be root of 40. So pretty easy. Now we realize this side is root of 40. So the perimeter, here you go, is equal to the sum of all the sides. So root of 36 plus root of 36 plus root of 40, that should be 18.3245. Correct to 2 decimal place should be 32 centimeters. I think here we have to use units because we don't know the quantifier. Okay, so that will be question part 2 into finding the perimeter of the triangle ABC and giving your answers correct to 2 decimal place. Let's move on to the next question. The diagram shows a metal plate ABCDE, given to you right here, which has been made from removing the 2 sides, 2 regions here, as you can see, removing these 2, and then we can form that metal plate. Now let's move on. From a circle, radius 10 and center O. Okay, they're given to you. If this is 10, this also will be 10. This is the radius as well. Now the edges, AB and ED are both of length 12. So this is 12 and this is also 12. Okay, good to know. What else do we need to do now? So part 1, we have to show the angle DOE is 1.287 radians. So we have to find this angle. So pretty easy. If you look at this shape, we have angle, we have triangle, ODE. When we know all the 3 sides of the triangle, we have to find the angle in between here. We can use the cosine rule. So you can write cosine of the angle O should be what? Should be equal to 10 square plus 10 square minus 12 square over 2 times 10 times 10. Again, these formulas you have to know when solving this kind of question. Okay, it is not going to be given to you. So 10 square plus 10 square minus 12 square, that is this, divided by 2 times 10 times 10. Should be this. Now we know that cos of the angle O is 0.28. Here we have to use radians, so cos inverse of that will be 1.287, correct to 4 SF. Shown as required, angle O is this one. Okay, great. Now next step, part 2. We have to find the perimeter of the metal plate. Okay, so how can you find this? So let's think. Perimeter is a shape, is a distance around the object, so we have to find this length, this length, this length, and this length. So here we know this is 12, this is also 12. So we know 2 things already. So we have to find this and find this. But something we can do here, we can find this one instead, right? Because we just have to remove this one. So let's find D. So how do you find the length of arc? We take the formula, which is the radius times the angle in between. The radius is 10. The angle we just found is 1.287. That will be 12.87. Now DE is 12.87, which means BA is also 12.87. So BA plus DE have to be 2 times this, 25.74 of the length that we don't need. We don't need those, right? So how can we use this? So if you think, we can find the circumference of the whole circle and then minus these two sides. If that makes sense. So what is the formula for circumference of a circle? That should be 2 pi r. So 2 pi is pi, radius is 10. That should be 20 pi is the circumference of the whole circle. Now we understand that we don't need these two sides. We can minus this one. So that will be 20 pi minus 25.74. So right now we have this one and this one. So we still have to add these two. So plus 24 for the perimeter. Minus 25.74 plus 24. That will be 61.1, correct to 3SF. Okay, so now part 3, find the area of the plate. So to find the area, we have to remove these two. So first, let's find the area of the whole thing, right? So it's area of a circle. That will be pi r square. R square is 10 square, which is 100. Pi will be the area of the whole thing. Now, we know that this and this are the same thing, right? We can find this one first. So how would you find the area of this? So pretty easy. We find the area of the whole sector and minus the area of the triangle, right? So let's do this. Area of sector is given to you by half r square theta, which is the angle. So these, you have to know this, right? And then minus the area of the triangle here, ODC, so we can have only this one remaining. So that will be, triangle is half times sine of the angle in between, and times the two sides around the angle. That is definitely one of the ways to find the triangle, area of triangle. But of course, you can use the other way, which is just half times base times height. For example, half is half, base is this one, 12, height is this one in between. You have to find the height. But I don't want to find the height to waste time. I can use just this formula to find the area directly. So simplify, half times 10 square times 1.287 minus half sine of 1.287 times 100. That should be 16.35 for the value of this part. Now we have this and this because they're the same, so multiply by 2. So unwanted area will be this times 2. That should be 32.7, this one. Okay, so finally, to find the area that we want, which is the area of the metal plate, it is the whole thing minus 32.7. $281.459. That will be 281, correct to 3SF. 0.0 if you want to. We have to write centimeters square. Now again, let me double check this value over here so I don't make any mistakes. That should be 50. Sorry. So half 50 times 1.287 minus 50 sine of 1.287. Yep, seems to be correct. So that will be your area, correct to 3SF for part 3 of the question. Let's move on to the next question. The diagram shows a rhombus ABCD in which the point A is minus 1, 2 and C is 5, 4, given to you right here. Now, and the point B lies on the y-axis. Great. Now what else? Part 1, we have to find the equation of the perpendicular bisector of AC. So first we have to understand what are we trying to find. For example, if we have a line AC, we join them together. Okay. Now, the perpendicular bisector is a line passing through the midpoint of AC at 90 degrees. So we have to find this equation. This is the perpendicular bisector at 90 degrees passing through the midpoint. So let's first find the midpoint. So to find the midpoint, we obviously will be using the formula, which is x1 plus x2. So 5 plus minus 1 is 4. Then divide by 2, that should be 2. 4 plus 2 is 6. Divide by 2 should be 3. So the midpoint is this. Now to find the equation of a straight line, we obviously have to find the gradient. So because they are perpendicular, we understand that the gradient of P multiplied by the gradient of AC have to give you minus 1. So this is the relationship between two perpendicular lines. Now you have to know this, okay? Now to find this one, we have to first find this one. So the gradient of AC can be easily found by using the 2 points. So y2 minus y1, so 4 minus 2, over x2 minus this should be 5 minus minus 1. That should be 2 over 6, 1 over 3. From this, we conclude the gradient of P should be just minus 3. So we have the gradient, we have the passing point, we can find the equation pretty easily, right? So xy, so y now we can cross multiply. Y minus 3 should be minus 3x plus 6 plus 9. Now here you go. This is your line, which is P, the perpendicular bisector of AC. Okay, good to know. Now part 2, we have to find the coordinates of B and D. So as you can see, B is on the y-axis. It is the point of intersection of this line and the y-axis. So pretty easy. To find the point B, it is at the value where x is equal to 0. It is because it is on the y-axis. So replace back in your equation. Y will be 0 plus 9, and that will be 9. The point B will be 0, 9. This is the value of 9. That's the part 1. Now we have to find the point D. Now in this case, we can just use vector movement to go to point D. For example, we understand that the length here and the length here are the same, right? Now how can we move from B to the midpoint? If you think, we have to move, this is 2 here, sorry, this is the point 2 and 3, right? 2, 3. Here we have 9. We have to first move 1, 2, right? So 1, 2 to the right, so 2 to the right is 2, and we have to move from 9 going down to 3, we have to move 6 down, minus 6. So when you go right, it is positive. When you go down, it is negative. If you go left, it is negative. If you go up, it is positive. Okay, just so we are clear, how do I get those values? At first, you have to move right or left. So we move right by 2, so that is plus 2. Then we move down by 6, so moving down is minus 6. So from B going to M will be 2 minus 6. Now same thing, from M going to D will be also 2 minus 6. So the idea is M is given to you by the point 2, 3. We plus the movement of 2 minus 6 should be simply 4 minus 3. So the point B is this, the point D will be 4 minus 3. That is part 2 of your equation. Now let's move on. What is the area of the rhombus? How would you find the area? So pretty easily. There's many ways to find the area. In this case, we can break this down into 2 pieces and find the area of the triangle here times 2. So let's do that, why not? So how would you find the area of a triangle, of a right angle triangle? So let me explain. I'm just breaking down the rhombus into 2 pieces. I have a piece on top, which is BAC, right? That's the piece on top. This is B, A, and C. I'm trying to find the perpendicular height in between. This is the point M. So let me find the length of BM. How would you find the length of BM? Using your formula, which is, I know the point B is given to you by, let me write this down, B is 0, 9, and M is given to you by 2, 3. So pretty easy. X2 minus x1 is 2, square is 4, plus y2 minus y1 is minus 6, square is 36. So length of BM will be root of 40. The next one. So the perpendicular height will be root of 40. Now we have to find the base. What is the length of AC? Square root. So we know the point A is this, and the point C is given to you by 5, 4. So again, using the formula, which is x2 minus x1 is 6, square is 36. 4 minus 2 is 2, square will be 4. Again, same thing, root of 40. So replace, that will be root of 40. So area of this triangle will be half times base and times the perpendicular height. But now again, this is just the area of this top piece, so we have to find the whole thing. So this, and at the bottom will be times 2 because they're the same, right? That should give you what? Cancel out, and that should be just 40 units square for the area of that rhombus. Again, this is just one of the ways to find the area. Obviously, there's other methods you can use to find area when you know all the points. Let's move on to the next question. The diagram shows part of the curve y equal to x plus 4 over x. Now, first thing first, I can think of doing what? I can think of rewriting this as x plus x 4x power minus 1. Again, you don't need to do that. It is just something that, in case we have to use something like that, right? Now, we understand that it has a minimum point at M. This is the minimum point right here. The line y equal to 5 intersects the curve at the point A and B. Now again, you have to understand there's a reason why they're giving you all these values in the question. So this is the point A and B. Let me draw these two lines so I can mark the x values of the point A and 2B later on. Now part 1 is I have to find the points A, B, and M. So let's start with A, B, and then find AM. Now we understand that the point A and B are the point of intersection between the straight line and the curve. So we have to solve the equation simultaneously. So here we have equation number 1, here we have equation number 2. So replace. On one side you have 5, and you have x plus 4 over x. Now here we have x at the bottom. We want to definitely remove that. To remove the x, we have to multiply by x everywhere. So that will give you what? You will cancel out the x at the bottom. You will have 5x plus x squared plus 4. So equal to 4, sorry. I think this one is equal here, and that is plus here. Apologies. Now I have to rearrange. Let's send everything to this side. You will have x squared minus 5x plus the value of 4 should be 0. Now we have a quadratic equation. We can factorize. We can use your formula if you want to. X times x, 4 is 4 times 1. To get minus 5, we have to have minus 4 minus 1. X will be 4 and x will be the value of 1. Let's find the corresponding y value. This is 5 and 5 obviously, because we know this is the line 5, right? So the point A will be here before. A will be the point 1, 5, and B will be the point 4, 5. Because A happens before B, so we know this is 1 and this should be 4, right? Now there is a point A and B, so let's find the point M. M is this one. So to find M, we have to look at what? Because we know M is a minimum point, and we know that at the stationary point, dy by dx have to be 0. So let's solve that. You will have, using this one, right? It's easier. That will be 1, right? And then first multiply by the power, then minus 1 to the power should be this. Then we can rewrite this as, send this over here, will be 1 equal to 4 over x squared. That should be, x squared should be 4, and from this, x should be the value of 2. Obviously, you will not take negative 2, because you can see here, it is on the positive side, right? It can only be 2 here. It cannot be negative 2, obviously, right? Now, what is the y value? Replace back in your equation of your curve should be, x should be 2 plus 4 over 2, that should be 4. So the point M is 2 and 4. That is part 1 of your question. Now what else do we need to do? So here we have to find the volume obtained when the shaded region is rotated about 360 through the x-axis. Okay, so now this is pretty interesting. It is not very hard, but we just have to use a bit of imagination. So at first we want to rotate this region around the x-axis to find that volume, but we can break this down into two pieces. For example, I have my x-axis here. I first rotate this line. For example, if I rotate a straight line around the x-axis, what would that give you? Let's think. This is my x-axis. I have a straight line over here. I'll go around the x-axis, right? I'll go around the x-axis. As you can see, this will give you a cylinder, right? And the radius is what? The height is 5. So the radius is 5. And what is the length? The length is between 1 and 4. That should be 3. So the whole volume, everything, when you rotate the line, the whole thing, the bigger volume is volume of a cylinder. So let me find that first. Volume of cylinder is equal to pi r square h. So pi is pi. R square is 5 square. H is the height, which is 3. Right. Now let's simplify. That will give you what? So 25 times 3 is 75 pi, and that should be units cube for the whole volume. Now everything right. Now you have to remove the volume obtained, which is rotated under the curve, because you only want the top part. So when you rotate the curve now, right? So the curve is something like this. This is the x. Now when you rotate the curve, for example, between these 2 points, right? Let's say there's something over here like this. You want to remove this one. So you're only left with this volume over here and the volume over here. So how do you find the volume below curve rotated about the x-axis? We use our formula, right? So volume, unwanted volume, which is volume under curve about the x-axis. We'll have to use this one. Pi, and then that'll be y squared respect to dx. So again, this is the formula you have to know. Okay, memorize if you need it. When it is about the x-axis, we have to write y squared. Now this is this, and the limits obviously is 4 and 1. Y squared is what? So here we have y. Let's find y squared. So let me write this down over here. Y is given to you by x plus 4 over x. So y squared will be what? Will be x plus 4 over x squared. Now we can expand this, right? That will be x squared plus 2 times x times 4 over x plus 16 over x squared. X squared cancel out, you'll be plus 8 and plus 16 x power minus 2. So here you go. Y squared is 8 plus x squared plus 16 x power minus 2 dx. This one will be pi, and then will have 8x plus x power 3 over 3. Then we have 16 here as a multiple, then plus 1, that should be minus 1 divided by this. Limits are 4 and 1. So let's see, that will be 8 times 4 plus 4 power 3 should be 64. And here we have minus 16 over x is 4. That is for the first part. Minus, now when x is 1, that should be 8 times 1 is 8 plus 1 over 3. And here we should have what? Minus 16 over 1. Okay, let's simplify one by one. For the first one here, we have 8 times 4 plus 64 divided by 3 minus 4. That should be 49. This is 49 1/3. Minus this one is 8 plus 1 over 3 minus 16. That should be minus 7 2/3. Okay, so finally that should be what? Let's see. 49 1/3 minus 7 2/3. That should be 57 pi units cube. Now this is the area or the volume that we do not need. The volume below curve that we get through rotation, we don't need that one because we need the top part. So pretty easy. The volume that we need is the whole thing, 75 pi minus 57 pi. That will be what? 18 pi, which is 56.5 units cube for volume, correct to 3SF. And that will be part 2 of your question again. Step by step, think about this in 3 dimensions. Use your imagination step by step. So first thing first, when you rotate this whole thing, we can first rotate the outer layer, which is this straight line. When you rotate this above the x-axis, you will get the whole cylinder. If you think about this, use your imagination. Right. Now, we only want the top part of the volume, so obviously you have to remove the bottom part. The bottom part, it happens to be the area under curve or the volume under curve. Now the volume under curve, which is rotated about the x-axis, tends to be found by using your formula right here. So using that, you find the relevant values, and then in the end you subtract to find the following answer for the volume of that region. Let's move on to the next question. The function f of x is given to you by this. Okay, now first thing I do realize is that the coefficient of x squared is 2. It is a positive value, so I can kind of understand the shape will be something like this, right? If the coefficient of x squared is positive, I can understand the shape will be something like this. Again, anyways, there's something good for you to know. Now part 2, we have to find the values of k, for which the line, this, is a tangent to the curve this. So pretty easy. Tangent means it only meets the curve at one point, right? Because of that, we understand the discriminant, which is b squared minus 4ac, have to be 0. So this means this and this means this. So we have to use that to find the value of k. So first we have y equal to f of x as this one, and y is equal to 12 minus kx. So we have to solve the equation first simultaneously. On one side you will have 12 minus kx is equal to 2x squared minus 8x plus 14. Let me send everything to one side. You will have 2x squared minus 8x plus kx plus 14 minus 12 is plus 2. Simplify. That should be plus here k minus 8 factorize x plus 2 have to be 0. Now this is the value of a, value of b and c. So b squared is this one minus 4 times a times c have to be 0. Solve k minus 8 squared, and that should be equal to what? Oh, minus, let's see, 4 times 2 times 2 should be 16. So we have 16 over here. So k, we can find the critical values for now, right? Oh, we don't need to, because here we can see we can find the values of k. So we have two values. K minus 8 should be plus minus root of 16, which is plus minus 4. K minus 8 can be 4, or k minus 8 can be minus 4. So k should be 12, and k should be the value of 4. So these are the two possible values of k for which it is a tangent to the point, to the curve. That is part 1. Now for part 2, we have to express f of x in this form. So we're basically completing the squares. So one by one, here we have 2x squared minus 8x plus 14. The first thing we'll look at is the coefficient of x squared. It happens to be 2. We need to change this to 1. So we factorize. That will be this, and that should be x squared minus 4x. And for this one, we can just leave this outside. No big deal. Now this is 1 now. We can proceed to the next step. Here we have 2. Here we have x squared minus 4x. We have to add something. We add the value over here, which is 4, divided by 2 square. plus 14. Now when you add something, you have to remove the same thing. That should be 40 divided by 2 is 2 square. Now since it was inside the bracket, we have to also give it the value of 2. So simplify 2. Here we have x, right, x minus, inside we have 2, and here we have square. So this becomes this. That's the main idea for this step. Now we will have 14 minus 2 times 2 square. That should be 6 plus 6. Okay, this in the form of this will give you this 2x minus 2 square plus 6. That is part 2 of your equation. Now part 3, find the range of f. So pretty easy. We understand that the shape will be somewhat like this. Now again, there's a reason why they asked you to change that into this. When it is into this form, we understand that the value at the back is the stationary value, right? In this case, it is a minimum value. As you can see here, it should be the value of y is 6. Now the range, 6, that will be 6. Now, the range is what? It is the value of y. As you can see, the curve is always going to go up from here. So we describe this as f can be more or equal to 6, or you can write y is more or equal to 6 as seen by the shape of the diagram or the curve. And this is part 1, part 3 of the question. Now for part 4, the function g of x is the same thing, defined for a is more than a. So x is more than a. Okay. Now question, find the smallest value of a for which g has an inverse. Now we have done this question many times before. A function have an inverse if it is a one-to-one function. For example here, as you can see, if I draw a line, I'll have 2 points of intersection. So it will not be a one-to-one function. Because of that, we don't have an inverse. Now, what can I do to make this have an inverse is by restricting the domain or restricting the value of a. For example, I have this. I can remove this whole side of the curve by restricting the value of a of x to be starting from this point more than the value over here, so that I only have this part of the graph. And when I draw a line, I'll have only one point of intersection, and that will make this become a one-to-one function and hence have a inverse. Okay, so what is this point over here? So pretty easy. We know that this point is the minimum point. It will happen when the value inside here, which is x minus 2, is 0. So x will be the value of 2. So x has to be more or equal to 2. That is the smallest value of a possible. It is only 1 mark, not too hard. Now again, something very clear. The point over here, it is just the minimum point of that curve. If you guys don't understand those steps, no big deal. How do you find the minimum point or the stationary point of a curve? Use dy by dx equal to 0 and then solve one by one. Up to you. We can use these values already, or you can do dy by dx to solve this, because sometimes we kind of have a hard time to use this thing to solve it. But again, this is the easiest way to do this. Okay, so let me move on to the last one. For this value of a, find g or inverse of x in terms of x. So pretty easy. First step, let the value of y equal to g of x. That will be, as we can see, it is this one, right? 2x minus 2 square this. Makes x become subject, so I have y minus 6. That should be x minus 2 square. So x minus 2 should be plus minus over 2. X will be plus minus over 2. Now since we know that x have to be more or equal to 2, we have to take x, only one of the values. X will be 2 plus y minus 6 over 2. And finally, g inverse, it is in terms of x, so we have to change the y over here to x. That will be 2 plus, okay, and that will be your answer for question part 5 into finding this expression. Again, let me just do a recap for this part. Pretty easy. So whenever you have to express your function as a complete square form, a plus b square plus c. Now, If the question is asking you to find the stationary point or the minimum point or the maximum point, we'll look at the value inside and the value at the end. So the value at the end is the y value, something you have to know at this point. And the value inside, we just have to equate that value inside to 0 to find the x value. So in this case, it is the stationary point, x value is minus b, and c. For example, this will be that. So I hope you can use that now to find the stationary point of a curve, and then hence, so you can use the understanding of that to find the following answers in this question.